I welcome all of you to this revision class before class test. So some concepts of engineering mechanics we will discuss today by some numerical problems. So first numerical problem, this is from equilibrium chapter. So what is the problem statement? Determine the magnitude T of the tension in the supporting cable and the magnitude of the force on the pin at A for the jeep crane shown. So this blue colored body is the jeep crane which is supported by this tension cable. Okay, this is the tension cable. So we need to find out that what is the amount of tension in this cable. So it is weighted, the load is carried by the cable. So the supporting cable, it will have some tension within it. Let us assume that it is T. So this tension we need to find out. And second thing is the magnitude of the force on the pin A for the jeep crane shown. So here, okay, we need to find out the magnitude of the force which is working. Okay, so we don't know in which direction it is working, but we need to find it out. The beam AB is a standard 0.5 meter I beam. So 0.5 meter, this distance is 0.5 meter. Okay, in the cross section I think you can better identify that this is a I type of shape. Okay, I kind of shape. So here the height is 0.5 and cross section is I, that is why I beam, with a mass of 95 kg per meter of length. Okay, so per meter of length, total how many meter is there? 5 meter is the net length. So 95 kg per meter. So you can find out the total mass of the body. So let us see how to solve this problem. So first of all, we can calculate the net weight of the beam. So 95 per meter into 5 meter. Okay, so into G 9.81. So that is the weight in Newton unit. So if we want to convert it into kilonewton unit, then we need to multiply 10 to the power minus 3 with it. So the answer is 4.66 in kilonewton unit. So this is the weight. Okay, now we shall draw the free body diagram of the system. So which body is our consideration? The beam is our under consideration or attention. So the free body diagram of the beam should be drawn. So this is the free body diagram. Okay, this is the rectangular beam. So in this first you need to show this tension in the cable. Okay, so this is the tension in the cable. The angle with the horizontal 25 degree, that is given. Now there is a load of 10 kilonewton exactly at this point. So from B end, what is the distance? That is also given 1.5. So at a distance of 1.5 meter, draw 10 kilonewton of force. Now the weight of the body, that is 4.66 Newton, we had calculated. So that should be working through the center of gravity of the body. So this is a simple rectangle. So center of gravity of this rectangle is half of the distance. Okay, so total distance is 5 meter. So at 2.5 meter from the B end, this is the point of center of gravity. Okay, so 4.66 kilonewton force will be acting through this center of gravity. And at A, two reaction forces we need to show, because we don't know exact direction of the reaction. Okay, maybe the resultant of AX and AY be the direction of the reaction. Okay, so let us assume two reaction forces AX and AY. Now we need to go for solution by the equilibrium equation. So first of all, if we try to find out the moment about point A, then what will happen? Then two unknown forces AX and AY, moment of these two forces will become 0 because they are acting on the point A, so distance is 0, that is why the moment will be 0. So let us take moment about A, summation of moment about A is equal to 0. Okay, this one. So from T, so T is in angle. So Varignon's theorem says that the resultant force, moment of resultant force is equal to moment of its components, sum of moment of its components. So that is why basically the T is have two components. Okay, it is in certain angle, so it has two components. One is T cos x, another one is T sin T cos theta, T sin theta. This is T sin theta, T sin 25 degree. This is T cos 25 degree. So moment of T cos 25 degree plus moment of T sin 25 degree, that is equal to moment of T as per the Varignon's theorem. So what is the moment for T cos 25 degree? So this is the T cos 25 degree. This point is A. What is the distance? Distance is 0.25. Okay. So T cos 25 degree into 0.25. And this is working in the counterclockwise direction. So let us take counterclockwise direction as the positive for moment. So it will be plus T cos 25 into 0.25. Now next, T sin 25, the vertical component. What is the distance with the vertical component? So the distance is this is 5, but some amount of offset is there. Okay, because the A is not exactly at the end. Okay, but it is little offset. The offset dimension is 0.12 meter. So 5 meter minus 0.12 meter. Okay, so T sin 25 degree into 5 minus 0.12. Now let us talk about the vertical force 10 kilonewton, which is due to the weight. So what is the distance of A and 10 kilonewton? Net distance is 5. So this 1.5 will be subtracted and this 1.2 also will be subtracted. So from here to here, this distance we can find out. Okay, so minus 10, minus because this is a clockwise movement. So minus 10 into 5 minus 1.5 minus 0.12. And at the last 4.66, the weight. Okay, so 4.66 into the distance. What is the distance? This is half. That means 2.5 minus the offset distance. Okay, 0.1. So minus 4.66, 2.5 minus 0.1. This is also minus because this is also clockwise. So in this equation, the total equation summation of m equals to 0 is written. In this equation, only one term you don't know, that is T. Okay, so find out T. So this is a simple algebraic equation. There will not be any difficulty to solve this equation, and you will get the value of T, and that is 19.61 kilonewton. Now when you know this value of T, then you can easily write the summation of fx equation and summation of fy equation. Okay, because we need to go further because we don't know what is the value of ax and ay. So in the direction of x, how many forces are there? One force is ax and other force is t cos 25 degree. So t cos 25 degree means 19.61 cos 25 degree. So we can write ax in the positive direction, in the negative direction, minus 19.61 cos 20 degree, that should be equal to 0, So that means Ax is equal to 19.61 cos 20 degree, and that is equal to 17.77 kilonewton. Similarly, in the y direction, how many forces are there? 1, 2, 3 and 4. So in the positive direction we can write Ay and plus t sine 25 degree. T means 19.61 sine 25 degree, and in the negative direction 4.6610. So write all of them and you find out the value of Ay, that is 6.37 kilonewton. So in this manner we can find out Ax and Ay. Why we need to calculate A. Okay, what is the modulus of vector A? So that modulus is root over of Ax square plus Ay square, and that is equal to 18.80. This is the value. Okay, this is the modulus of A. If they are asking for the angle, that also can be calculated from tan inverse Ay by Ax. So this is the solution of this kind of problem. Okay, now let us talk about the next problem. So this one, if the wheelbarrow and its contents have a mass of 60 kg and center of mass at G. So this is the wheelbarrow and this is the center of mass G, and mass is 60 kg. Determine the magnitude of the resultant force which the man must exert on each of the two handles in order to hold the wheelbarrow in equilibrium. Okay, so this is an equilibrium problem. What they are asking, determine the magnitude of the resultant force which the man must exert on the two handles. Okay, so the man is exerting some force on the handles. So that force we need to find out. So this is the solution. Okay, let us see how to solve. First we need to find out the free body diagram. So the wheelbarrow is the system which is under our attention. So this is G. So from G the net weight is working. Net mass is 60 kg. So 60 into G, 9.81 Newton of mass will be there. Reaction force will act at A. So only a vertical reaction force will act because it is a wheel. Okay, so there is no restriction in the x direction. So only restriction in the y direction. That is why only Ay, only the only reaction force. Okay, the geometry, from the geometry we can find out that the G is at 0.6 meter from the ground. Okay, and from A it is at 0.5 meter. All other dimensions are given, and at B we don't know what is the direction of the force exerted by this man. So let us take two components of the force. Okay, so one component is Bx and other component is By. So first maximum number of unknown forces is at B. So if we take moment about B, then moment due to these two forces will become 0, and it will be easier for us to solve the problem. So let us take moment about B is equal to 0. So from Ay, what is the moment? This is Ay into 0.5 into 0.9. Okay. Now this time let us take the clockwise moment. Okay, because this is clockwise moment. So let us take this clockwise moment as the negative moment. Okay, as per our convention. So Ay into 1.4 minus sign, that should be equal to moment due to the weight. So what is moment due to the weight? So moment due to weight is 60 into 9.81 multiplied with 0.9, the distance, and that is positive because it is the counterclockwise moment. So in this equation only ay is unknown. So if you solve this algebraically, you can find out the magnitude of ay. Okay, so ay you had calculated. Now we can go for solving summation of fx and summation of fy. So in the direction of fy, the direction of y, how many forces are there? 3 forces are there. Okay, one force is this by, other force is the weight, and third force is the reaction at ay. Okay, now one thing we must understand that by is not a single force, okay, because two hands are there. Okay, in two hands obviously the worker is holding it. So in two hands, by plus by, 2 by amount of reaction force, 2 by amount of force will be exerted by this man. Okay, so write one by one. This is ay. Ay is 378.39 minus weight plus 2 by. This is in the positive direction, that is why plus. So 2 by is equal to 16 to 9.81 minus 378.39. So by is equal to 105.11. So this is the one answer. And second answer is summation of fx equals to 0. So in the direction of x, only bx is there, no other forces. So under the action of only one force in one direction, if a body is in equilibrium, then the only possible case is that single force is nothing but equal to 0. Okay, because there is nothing to balance bx in the direction of x, but the body is in equilibrium. So we can conclude that bx is equal to 0. So that is why we will write bx is equal to 0. So force at B. So one component is 105 and other component is 0. So net force is 105 Newton here. So this is the second problem. Now let us talk about third problem. This problem is from friction. Determine the range of values which the mass m0 may have so that the 100 kg block shown in the figure will neither start moving up the plane nor slip down the plane. Okay, so range of values of mass, range of values of this dead mass. Okay, so this mass 100 kilo is on rest on this wedge. In the other side, by means of a pulley and a rope, some dead mass of m0 value, okay, that is there, in order to maintain the equilibrium. Now at this condition, two things may happen. One, if you increase m0, you are increasing the value. After a certain value of m0, the block will slide up direction. Okay, when it will increase such a value, then the block will gradually rise up. Okay, that means the equilibrium condition will be changed. It will not be in the equilibrium. And second thing is, you can decrease the value of m0. So if you decrease and decrease, at certain level of value, the block will slide down. So the minimum value of m0 and maximum value of m0 for which the equilibrium can be maintained, that range we need to calculate. The coefficient of static friction is given, that is 0.30. Okay, now let us see how to solve this problem. So first of all, you draw the free body diagram of this problem. So in the free body diagram, you draw the block, then you draw the normal reaction because it is always normal to the surface, to this surface also. Then you draw the weight of the body, so 100 kg into 9.81, that means 981 Newton. That will always act in the vertical direction. Okay, and we know that from geometry, if this angle is 20 degree, this is also same 20 degree. Okay, that is also we know from geometry. Okay, this it is 20 degree, this is also 20 degree. So then we next consider two cases. So one extreme cases is when m0 is maximum and the motion of the mass 100 kg is impending upward. Okay, that means at the limiting condition. If we increase further the value of m0, the block will rise upside. Okay, but it is at the limit right now. That time the friction force is working against the tendency of the movement. So tendency is upward, so friction force will be acting downward. Okay, and the tension will be acting in the direction of, suppose this direction is x. Okay, in the direction of block, the wedge. Okay, wedge surface, that is x, and the tension value of T will be how much? That should be equal to the weight of the dead mass. If you consider the free body diagram of the string, or if you consider the string is a single body, so the tension in this string will be constant throughout, and that tension is here is how much? Due to the weight of the body. So in this portion, if you draw the free body diagram, that is T is in the vertically up direction and m0 0 is in the vertically downward direction. T is equal to m0 g. So here also T will be equal to m0 g. So that T value we are giving. So this is the case 1. Now if you solve for this case 1, so in the direction of y, how many forces are there? So this is direction of y, this is direction of x. So n is equal to 981 cos 20. Okay, n is equal to 981 cos 20. You don't know the value of n only, so the value of n you can calculate. That is equal to 981 cos 20. That should be equal to 922 Newton. Next, let us find out the limiting value for f max. Okay, which is a known formula. F max is equal to mu s into n. This is the limiting condition. So this is the friction offered by the surface is F max right now. So that is equal to 0.3 into 922. N you know, mu you know, so you can calculate. That is equal to 277 Newton. Now in the direction of x, let us solve for the equilibrium. So in the direction of x, in the positive direction we have T. T is equal to m0 into g. So m0 into g in the plus direction. In the negative direction, f max is there, minus 277, and x component of 981. So 981 sin 20, that is equal to 0. So in this equation only m0 is unknown. So value of m0 is equal to, you can calculate, and that it should be 62.4 kg. Okay, so this is the highermost value of m0 for equilibrium. Next consider the lowermost value, second case. So in the second case, when it is minimum, then the block is impending downward motion. So the only thing that will change, that is the direction of this F max, and that should be opposite direction. Okay, when the block is moving downward, impending to move downward, then the friction force will act in the upward direction. So in this equation, the vertically there will be no change. So n will be equal to 981 cos 20. So the value of n will also be the same, 922 Newton. Okay, if n is equal to 922 Newton, then there is no change in the F max, because it is mu S, that is 0.30 into 922. So it will be 277 Newton again. Now in the x direction there is a change. That is what? Now in the positive direction, two forces. Okay, one is m0 t, so m0 into 9.81 plus 277 frictional force. In the negative direction, we have a component of weight. Okay, the negative direction, in this direction. So that is 981 sin 20 degree. So here in this equation only m0 is unknown. Algebraically we can solve. The value of m0 will come 6.01 kg. So in the minimum case it is 6.01 kg. In the maximum case it is 62.4 kg. So the range of dead mass must be 6.01 to 62.4 kg for a condition in which the block will neither start moving up the plane nor slip down the plane. So this is the solution. Now we will talk about a very simple problem. This is also from friction. Determine the maximum angle theta which the adjustable incline may have with the horizontal block before the block of mass m begins to slip. Begins to slip means again impending condition. So this is the adjustable incline plane, okay, which you can adjust. That angle you can adjust. Angle theta is the angle with the horizontal plane. So if you increase or decrease the theta, if you increase the theta, what will happen? At certain value of theta, the block will slip. So we need to find out that particular value of theta. Okay, when the block will impending in the downward motion. The coefficient of static friction is given, that is mu s. So very simple. First you identify which we need to consider. So the block we need to consider. So this is the block. So weight will be acting in the downward direction. Normal reaction will be acting in the direction of normal to the surface. And frictional force will be acting upward direction because we are considering downward impending motion. This is theta. So this angle, okay, the angle between y and w will also be equal to theta. So let us write the equilibrium equation for this condition. So the equilibrium equation in the x direction is f in one direction, so minus f plus mg into, if this is theta, mg into sin theta. Okay, so f is equal to mg sin theta, you can write. The y direction, we have two forces, n in the positive side and in the negative side mg cos theta. So n minus mg cos theta is equal to 0, we can write. So n is equal to mg cos theta. So this is equation number 1, this is equation number 2. Now let us divide equation number 1 with equation number 2. So 1 divided by 2, we will get f by n is equal to mg sin theta by mg cos theta. mg will be cancelled, so tan theta. So f by n will be equal to tan theta. Okay, now this is the impending case. Okay, so in the impending case, F is equal to F max. Okay, so in place of F we can write F max, and that F max is equal to mu s into n, we know. So F max by n is equal to mu s. So we can write mu s in place of F by n, that is equal to tan theta max. Okay, theta max because it is the maximum possible theta for the static condition. So mu s is equal to tan theta max. So tan theta max is equal to tan inverse mu s. Okay. So that is how we can find it out. And you know that this relation oftenly it is used as a formula for solving this kind of problems. Okay, so you can also, my suggestion is to remember this equation. For this kind of inclined plane, maximum permissible theta is equal to tan inverse mu s. So the next problem, so this is from dynamics. A particle starting from rest moves in a straight line whose equation of motion is given by s t cube minus twice t square plus 3. This is the equation of motion for the particle. Find the velocity and acceleration of the particle after 5 seconds. So s is the equation of motion. So hope you remember that if s is the equation of motion, then equation of velocity is ds by dt. Okay, because this ds dt is first order differential, that is representing the change of displacement with respect to time, and that means velocity. And if you do the second time differentiation, that is d2s by d2 dt2, that will give you the acceleration, that means rate of change of velocity. So with this concept we will solve this problem. So s, the equation we write t cube minus twice t square plus 3. If we differentiate it, we can write ds dt is equal to, this will be 3 t square minus 40 plus 0. So ds dt is equal to 3 t square minus 40. Velocity is equal to 3 t square minus 40. This is the equation of velocity. So equation of velocity is now as a function of time t. So after 5 seconds we can calculate what is the value of velocity. So put t is equal to 5 into this equation. So 3 into 5 square minus 4 into 5, and that will give you 55 meter per second. Okay. So from this relation at any instance we can find it out, particularly starting from the rest. So at t is equal to 0, what should be the value? V is equal to 0. That time velocity is 0. At t is equal to 1, we can find it out. 3 into 1 square minus 4 into 1. Okay. In this manner, at any time we can find it out. So next, acceleration we need to find out after 5 seconds. So again, differentiate the equation. So d2s dt2 will be 6t minus 4. So write that after differentiation. So we can write d2s dt2 means a. So a, acceleration a is equal to 6t minus 4. After 5 seconds, okay, a is a function of t. So after 5 seconds, at t is equal to 5, we can find it out. That t is equal to 5, a is 6 into 5 minus 4, 30 minus 4, 26 meter per second square. Okay, this is the solution. So in this manner, if equation of the motion is given, we can find out equation of velocity, acceleration by differentiation. And if the equation of acceleration is given, so in the opposite direction we can go. That means from acceleration, if you integrate it, you will get velocity. If you again integrate it, you will get displacement. Okay, so in this manner we can carry on. So up to this was today's class. So uh, this is a very small division, okay, from the chapters, from certain chapters only we had already discussed. So best of luck for your examination. Do prepare. If anyone have any doubt regarding any problem today discussed or discussed earlier, or any problem from the text, okay, from you try to solve the question papers, you try to solve the exercises in the books, any doubt you can ask me. Thank you all. See you.